What's up guys, John here with Team Legit. Today we're going to do the build video for the ZMR Team Legit quad with the Overcraft PDB board. I've got a buddy of mine here and he wanted to build one, so what better way to do a build video? As you can see, I've got everything laid out here on the table. I've got my camera plates right here. I've got the arms, the landing legs, and we don't use the landing legs. We've got the top plate here, the middle plate, and we've also got the second middle plate that normally would sandwich the two arms. But we're not going to use that. We're going to use the Overcraft PDB with the integrated LEDs, all the solder points, and the PCB. Also has a voltage sensor and a buzzer. So one really cool thing about this frame, it'll give you a nice clean build. It'll allow you to solder all the ESCs directly to the board. So let's get started here. Okay, first thing we're going to do is grab our trusty little Allen key and driver set. These are going to be available here on the Team Legit store. You don't want to leave home without them. They're really good. They've got all the different hex drivers for a multi-rotor, a Phillips head, and a flathead screwdriver. Okay, anyway, so we're going to take out all of our motors from the packaging. So we've got all of our motors taken out. We're using the DYS Black Series motors, the 1806 2300 kV. So we're going through, taking out all the motors. There's a couple different parts bags. The first parts bag has these little bullet connectors and heat shrink. We're not going to need those, so we're going to go ahead and put those aside. The next things we're going to see is the little screws and nuts and things like that. So we're going to go ahead and separate them. There are long screws and short screws. Those are the only ones we're going to be concerned with right now. Okay, we're going to go ahead and take the prop adapters and install them on each one of the motors. There's going to be 4 short screws in the bag for the DYS motors, and you'll go ahead and just put the small screws into the prop adapter. We want to put them on there nice and tight. Make sure you use a good Phillips screwdriver. You don't want to strip the screws. So the next step, you're going to run the bolts into the motor. However, you have to be very careful because if you look right here, inside, there are wires. There's some wires that stick in right there, and one of these screws, so if you were to take these longer screws here and drive them into this, eventually that screw is going to go in and hit the wires. You're going to short it out and you're going to burn the motor. So you don't want to use the long ones there. You're going to use the long ones in the back 2 holes. The back 2 holes are going to get the long one, and then the front 2 holes are going to get the shorter ones, because we're going to have a bunch of shorter extra screws. So we're going to take this, we're going to line it up on the motor, on the arm, and the back 2 screws are going to get the longer screws. Okay, so once you've got all of the prop adapters mounted to the motors and the motors mounted to each one of the arms, we're going to go ahead and start with the ESCs. What you want to do is figure out the length of your ESCs versus the motor wires. In our case, we've got extra long motor wires, and we've also got extra long ESC wires. So what I'm going to do is cut off all the heat shrink very carefully, making sure we don't damage any of the components, and we're going to desolder all of the motor wires off of the ESCs. Then we're going to go ahead and solder the motor wires directly to the ESC, just the right length to fit onto the arms. This will help reduce quite a bit of weight and keep your wires nice and clean. Okay, now moving on to the motors and the length. So the motors usually come in 3 wires for brushless motors. There's going to be a motor wire 1, 2, 3, or also marked as A, B, C. What we're going to need to do is make sure 2 of the motors are spinning the correct way and 2 of the motors are spinning the other way. The best way to accomplish this is use the first 3 wires, say motor 1, 2, and 3, and solder them directly to the ESC in that order. You're going to do this for 2 of these ESCs and motors. Then on the other ones, you're going to replace them with any 2 wires. So what I usually do is solder motor wire number 1 to point 1, number 2 to point 2, number 3 to point 3. Then when I want to reverse them, I solder motor wire point 1 to point 1 and motor wire number 2 to point 3 and motor wire number 3 to point 2. This will ensure that your 2 motors spin clockwise and 2 motors spin counterclockwise. I always like to cut the motor wires directly to length, so that way they stay nice and clean and tucked away underneath the heat shrink. Okay, once you've got all your motors soldered to your ESCs, doing two of them in one configuration and two of them in the other configuration, we're going to go ahead and test out our motor to make sure that it's spinning in the right way. So what I usually like to do is just plug one of them up into a battery very carefully. I like to use my servo tester to test the motor. I'll just wind it up just a little bit just to make sure that it's spinning in the right direction. And then I'll go ahead and use a black marker and I'll identify on the arm which direction that motor spins. I'll usually write a little arrow underneath saying that the motor spins in this direction, and that way I can figure it out when I'm installing the arms onto the frame. And it also helps out later on down the line when you have a little crash and you break a prop. You can then figure out which prop goes on which arm, which direction does it need to spin. So once we've got all of our motors soldered up, we're going to go ahead and apply the heat shrink on there. You want to make sure you protect the ESCs from touching the carbon fiber. As you guys know, the carbon fiber is conductive. You will fry your ESC if you do not cover it up in heat shrink or black tape. Okay, now that we've got all of our arms assembled with the motors and the ESCs on there, we're going to go ahead and figure out the correct orientation of our motor spins and which arm goes in which position. Each flight controller is a little bit different, so make sure you check your flight controller to see which way your motor should be spinning. Okay, so we're going to be using the Dragonfly 32, which is the same flight control as the Naze 32, and it uses the base flight or clean flight software. So we figured out which direction our motors need to spin, and now we just need to go through and line them up to the PCB board. So once you figure out which motors go where and you know which direction they spin, you can put them on the quadcopter in the correct orientation. Now would be a good time to take a marker and maybe write on the bottom of each arm which motor you're going to be hooking up. Say for example motor number 1, 2, 3, and 4. And then also take the servo lead that you have that's going to be plugging into the flight controller and write down the 1, 2, and 3 and 4 numbers also corresponding to each one of the motors. This will help you out later when you're setting up the flight controller. Okay, now before we start assembling the arms to the quadcopter frame, we have to make sure we plan a little bit ahead. I've realized that when you put the arms in and you sandwich them down between the two plates, you can't get the standoffs in and you can't get everything else set in underneath. So what we're going to do is we're going to take out all of our little M3 screws with the hex bolts on them. These are the ones that hold the standoffs, the red standoffs, into place. And we're going to go ahead and put all of our standoffs in onto the PCB board. That way when the two boards are sandwiched together, we don't have to worry about accessing the screws. So I'll go through and go ahead and put down all the standoffs. Now would also be a good time to put the standoffs for your flight controller if you're going to be using the nylon standoffs like I like to use in the configuration for the motor. So go ahead and put all the standoffs that need to be protruding through the top of the board, and we'll move on to the next step. All right, now to the good stuff. We're going to go ahead and start assembling our quadcopter, and we're going to go ahead and put each one of the motors in their correct position. Motor number 1, 2, and 3. We would have already marked them. And the first thing I'll do is take one of the arms, sandwich it together with the bottom plate, stick the two bolts through, and then just lightly tighten the lock nut on the bottom. I only put two of them at this point. I don't tighten them down all the way, just until they're past hand tightening, because we want to be able to mount the rest of the arms into place by being able to pull the two plates apart. So what I usually do is I'll go ahead and slide the arm into place, drop the two bolts in from the top and the bottom, from the top, and then put the little bolt on the bottom. At this point, it's also a good idea to run your motor wires through the center of the plate for later plugging into the flight controller. So once you've got your quad fully assembled, we're going to go ahead and start soldering the wires directly to the PDB board. What we're going to go ahead and do is cut the wires down to length just so they reach the solder points, and then we'll go ahead and tin the solder points a little bit with some solder, and then we'll go ahead and tin each one of the leads from the ESC, the positive and the negative, and we'll go ahead and solder them down directly to the board. This will ensure a nice clean setup. What I like to do usually is I'll go ahead and put the wire down on the PDB board, hold it down with the solder, and then I'll find a pair of pliers or a screwdriver or something just to hold it down into place while the solder cools. Make sure we get a nice good solder. So now we'll go ahead and go through and do this for all 4 ESCs. Again, shortening the wires just to the right length, further reducing the weight on the quadcopter. Alright guys, moving on to the next step, we're going to go ahead and solder the pins onto the Dragonfly flight controller, the Dragonfly 32 here. The easiest way I like to do it is just put the pins in place, flip it upside down, and then tack each one of the corners of the pins with the little tiny bead of solder. Then I'll get some rosin, and we'll make sure we get a nice coating on all of the different pins that we're going to apply some solder to. And then we'll take our solder and just kind of go through and hit down each one of the pins, just making sure we get a nice solid solder point. You don't want to have any loose solder, or you don't want to have any solder points that aren't completely connected to the board. This could cause a lot of problems in the future. It's actually pretty simple to do, and goes pretty quickly once you do it right the first time. So I'll go ahead and zoom in here for you guys and show you how my buddy here is soldering down each one of the points. You want to be careful of any of those little blobs that connect there. The reason that happens is because there wasn't enough solder on the actual point. So the easiest way to fix that, if you do happen to have that, is just use your pullet, or pull it, however you pronounce it. You'll just go through the board and suck up any of the parts that connect together. Alright guys, if you're like me, you want to make sure you get the lightest and cleanest build possible. So what I like to do here is cut my servo leads even shorter than they need to be. So what I'll do here is I'll just get them down to about where they're going to be, where I mount the board, and I'll go ahead and cut the actual servo wires. And there's a cool little trick here about the flight controllers. You only need the signal wires on 3 of the motors and the BEC from the first motor. So what I usually like to do is take motor number 1 and cut down the servo lead down to size. Then I'll go ahead and take the red, black, and yellow wire, solder them back together, shortening the wires down to size so they fit the frame nice and clean. Then for the other 3 wires, what I'll do is actually cut the wires, clip the lead down to size, and remove the red and the black wires. Make sure that if you do cut the red and black wires that you don't leave the ends exposed to where they can come in contact with anything metal or carbon fiber. You don't want to create any shorts in your ESC. So I'll go through here and shorten down the wires even further to make sure that I get a nice clean build. And as you can see here, it's kind of tedious, but it'll make it look nicer at the end. So I'm putting on some heat shrink here onto each one of the individual wires to make sure they're nice and shielded. And I cut them right to the point where they'll sit underneath the flight controller, so you won't see any of the solder. As you can see here, I'm just lining it up, making sure it fits the flight controller in the correct way. And I'll go through here and clip the rest of the wires, clip the brown and red wire, and leave the orange wire. Then I'll take my extension here and cut it down to size. Again, removing the brown and the black and just simply connecting the signal wire. This is all you need for the other 3 motors. So motor number 1 will be my BEC powering my flight controller, and it'll get its power from the PDB board. Then the rest of the motors will be receiving power from the PDB board and just a signal from the Dragonfly flight controller. Alright guys, so the quadcopter is all built and everything. So we've got everything set up. I already plugged in the power, made sure everything works. The next part of it is the programming part. Now, I'm not going to get into the details on how to program your board because there's a lot of really good videos out there. My favorite one is if you just go to YouTube and you type in Naze32, there is the first video that pops up, which will be by Mocha Boy RC. It's currently got about almost 80,000 views. The title, the actual video is titled "How to Set Up Naze32 Acro Fun Fly." Now, I've watched this video and this is how I learned how to do it. So I credit a lot of the setting up of the Naze32 to Mocha Boy RC. So I'll let you guys watch that. I'll let you guys get your Naze32 set up, and then we'll come into the final buttoning down and getting everything tucked in. Alright guys, we're back. We got the quadcopter all programmed and everything like that, so it's pretty much ready for a flight. All we need to do is button everything down. So what we're going to do here is I'm going to show you real quick how to put the jello balls on and get the top plate ready to go. So one quick note, I wanted to show you guys, these are all the wires that we cut from here. So as you can see, these are all the little bits and pieces. So I wanted to show you guys real quick how much weight we've saved by doing that. So let's get the little scale on. Not to mention how clean it looks. Cutting all these wires, getting everything reduced down, not only makes it look cleaner, but we've also reduced the weight significantly. Let's put our little thing on there. Put that down to 0. And now you guys might be thinking, hey, that's not that much weight. But on a mini quad like this, 20 grams is what we've saved, basically cutting down and shortening all these wires. And the difference in weight is pretty much getting this cool looking PDB board with the lights and everything. Actually, we've actually reduced about, I'd say about 6 to 8 grams entirely on the entire frame. So, all right, let's show you guys a quick tip here. If you want to come on in here. This is how I put the jello balls on. I take a little wire from the scrap wires that we have here, and we are going to, there's a little trick I learned along the way. Stick that right up in through the hole. We're going to put the little jello balls. We're going to just grab part of the little jello ball right here. Might be easier going this way. So we've got the little jello ball right there, and pull through. That's it. No need to fart around with getting these little things in and shoving them at the screwdriver or things like that. Makes it very simple, very quick. Just run a little loop around the hook right there and pop it in. That's it. So pretty much the rest of the build is pretty self-explanatory. You're going to go ahead and bolt this top plate down using the small M3 screws, and you can try to button things down and tighten things up the way you like it. We're probably going to end up putting this receiver right back here. It still kind of allows a little bit of access to get into the USB, but we're going to put that here. We'll put our video transmitter on top. We're going to be running 5.8 gigahertz on this bad boy here, so the 2.4 and the 5.8, they're not going to interfere, and we'll put that down on here. The other thing too, you've got your little camera plate for your PZO 420. This thing just slides right into here, and then it's locked down on here. Quick suggestion, use double stick tape on here, and actually mount your camera kind of standing back a little bit, and I'll actually show you how to do that. Alright, so to mount your camera, you got your little camera mounting plate. Most guys like to stick it in here. You are going to need to clip the ends of the PZO because it sits a little bit too tall. But most guys like to just put it in here and bolt it right down. Well, you guys got to remember, this is carbon fiber, and carbon fiber is conductive. So if you stick this camera in here and you tighten that down, there's a chance you're going to short something out. And it has actually happened to me and another guy as well, too, that I told him not to, and he explicitly did it. So what I like to do is I like to use the double stick tape, and I just stack them up to stick them directly to the board. What that does is actually, so we got that plate here. I'm going to disconnect the power here. So we've got that plate here. What I actually like to do is mount my camera back to about here. What that does is it doubles up as one holds the camera away from impact, so if you do go straight down, you don't bust the lens. And two, if you do go straight down, the double stick tape will give and allow your camera to slide back a little bit without breaking components. So I like to use the double stick tape. I don't like to bolt it directly to it. Okay guys, now the last step after we got everything down is a couple tips and tricks that I like to do. So if you want to get in here and check this out, you got the top plate with the little Jello anti-vibration balls. I like to put zip ties around all 4 of the little Jello balls, because if you have a nice impact, this camera plate usually pops off and your GoPro or your Mobius go with it. In this case we're running the Mobius. I just have it simply Velcro strapped down. What I also like to do too is just to help with my camera angle, I'll usually put a little foam pad or a little something right here so the camera kind of has an upward facing angle and I can still lock it down tight. And the reason for that is when you're flying your little mini quad around and you're doing your little racing and things like that, you're going to be facing the ground most of the time. So you want to have a little upward facing angle, and that'll help you out with your camera. So another trick that we like to do is after you've got your receiver mounted, wherever you're planning on putting it, you've got your little antenna. In this case, we're using the orange RX, so we've got this nice long antenna here. Some of you guys may be using the FR Sky or a different video transmitter. You don't want your antenna to dangle and get caught on something. So what we like to do is take a zip tie, and if you line it up correctly, you can tighten it down there and then feed your antenna up to where you need it to go. Take a bit of heat shrink, and now you've got an antenna stand ready to go. Keeps your antenna from flopping into your blades and your props, and it also keeps it pointed nice and upright so you get a better reception. Alright, everything else, like I said, guys, is pretty self-explanatory. That completes the build of the ZMR Team Legit frame with the LED PDB. If you guys have any questions, make sure you guys put that in the comments below. I'll try to link all the components that I used also in the description. And if this video helped you build your little quad and get your things nice and buttoned down and nice and clean build, make sure you click the like button. And as always, don't forget to subscribe. I'm Johnny with Team Legit. Thanks for watching. Dominator version 2 is here, and I want to show you guys a couple quick tips and tricks when you get your goggles. These are a couple things that I like to do whenever we get the goggles. This is not an unboxing video or showing you the quality and things like that. I'm sure a lot of you guys are starting to get them and they're starting to trickle in. We got a nice big batch of them. We've shipped out quite a bit of them, and we're going to get another batch, so we decided we're going to carry the goggles in our store. For more information